Hi everyone, in this class we will discuss the basic electric circuit and some basic numericals regarding the physical quantities that we discussed in the previous video. So let's start. So we will revise what we have learned in the previous class. Okay, so we have learned that electricity is a form of energy, and obviously the flow of charges is nothing but the current. We have also seen the what is meant by charge. Charge is a physical property of a matter due to which matter experiences an electrostatic force. So there are two types of charges, positive and negative. We know that like charges repel each other and unlike charges attract each other. We have also seen that charge on one electron is 1.6 into 10 raised to power minus 19 coulomb, whereas 1 coulomb of charge is equal to 6.25 into 10 raised to power 18 electrons. So moving further, we have also seen that the free electrons present in the conductor are responsible for the current, right? So we have also defined the drift speed or drift velocity of free electrons, the speed with which free electrons in a conductor are attracted towards a positive terminal of a battery, that is known as drift speed or drift velocity. We have seen the current is equal to charge by time, that is the rate of flow of charge is known as current, or electrons flowing per unit time, that is known as current. So we can write the formula I is equal to Q by T. The SI unit of current is ampere. So we have also defined what is meant by 1 ampere current. When 1 coulomb of charge flows for 1 second, then we used to say that current is a 1 ampere current. So SI unit of current is ampere, which can also be expressed in smaller units like milliampere, that is 10 raised to power minus 3 ampere, as well as microampere, that is 10 raised to power minus 6 ampere. Moving further, we have also seen that what is meant by potential difference, that is work done to bring a charge from one point to another in a given electric field. That particular work done is known as what? Potential difference, or simply we can say work done by charge, that is potential difference. So we can have a formula V is equal to W by Q. Similarly, the SI unit of this potential difference is volt. Likewise, in ampere we can also write the SI unit as joule per second. Similarly, here in potential difference we can write joule per coulomb. Moving further, we have also defined 1 volt. When 1 volt potential difference is said, that we already defined, whenever there is a 1 joule of work is done to bring a 1 coulomb of charge from one point to another, then in that case we can say the potential difference is 1 volt. So we define the resistance, the property of a conductor to resist the flow of charge through it is called as its resistance. So we wrote the formula R is equal to V by I. The SI unit of resistance is ohm, right? So we also define what is meant by 1 ohm resistance. When 1 ampere current flows through the circuit, when there is a 1 volt potential difference, in that case we can say that there is a resistance of 1 ohm. So moving further, now we will discuss what is exactly the electric circuit. So here basic electric circuit is shown, in which there is a bulb, a battery and over conducting wire having switch is there. So we can say a continuous and closed path of an electric current is known as circuit. As you can observe in the slide, a continuous and closed path of an electric current, that is known as what? Electric circuit. So to draw a diagram we can write in this way: two terminals, positive and negative, constituting battery or a cell, and one switch which is right now open, one light bulb which is connected with the battery with the help of wire. So a continuous and closed path of an electric current is known as what? Electric circuit. So what are the components of electric circuit? That components we are going to see now. So some basic components are there, which you can observe in the slide. An electric cell, which can be shown by two lines having two terminals, positive and negative. Whenever there are two or more cells, we used to say it is a combination of cells. We used to say it is a battery. So there are also two terminals, positive and negative. One bulb we can show in this way, and open key and closed key. After a few minutes we will see what is open circuit and closed circuit. So open key means where there is a no current flowing in the circuit, which can be shown in this way. You can observe in the slide, right? And closed key with dot. Moving further, we have wire joint and wire crossing without joint. Then resistance can be represented in this way. Rheostat, that is a variable resistance, that is represented in the given figure. So next is ammeter to measure the current, and next one is voltmeter to measure the potential difference. So what are the basic electrical instruments that we normally use? So one is ammeter. Obviously you know that ammeter is used to measure the current. So it measures the current and it is always connected in the series. So in later part of the chapter we will see what is meant by series and parallel. So here it is voltmeter, which measures the potential difference, which always connected in parallel in the given circuit. So it is a galvanometer. Again, remember, galvanometer also measures the current, but one important thing regarding the galvanometer is it can detect even a very small amount of current, as well as it gives magnitude as well as direction of current, whereas ammeter just gives the magnitude of current, but galvanometer also gives the magnitude and direction of a current. Then we have a rheostat, that is a variable resistance. We can change the resistance of a circuit with the help of this instrument. You are observing the black insulator kept on the cylindrical shape. We can move that black insulator so that resistance of a given circuit can change. So then we have resistance box, somewhat similar to rheostat. We can apply a resistance to the given circuit of a known value. That means we have different keys having 10 ohm, 20 ohm, 50 ohm resistance, which are used to control the amount of current passing through the circuit. Nowadays we are using the multimeter, in which we can use voltage, current and resistance in a single device. So all these instruments are also available in the digital format. Moving further, what is meant by open and closed circuit? So when we say switch or key is open, that means there is no current flowing through the circuit. That means circuit is off. Similarly, whenever there is a switch or key closed, then that means current is flowing through the circuit and circuit is on. So two figures are there in which open switch on the left side and closed switch on the right side is shown there. So open electric circuit, as you are observing, there is no current flowing through the circuit, and in case of a closed circuit, current is flowing through the circuit. Moving further, what is the direction of current? When electricity is discovered, there are no electrons discovered yet. So we have taken the direction of a positive charge to the direction of current. So we can say conventionally the direction of current is taken as from positive to negative, as electrons were not discovered at that time. So what is the direction of electrons? We know that electrons are negatively charged particles, so they will be attracted toward the positive terminal. So electrons will move from negative to positive, whereas current will move from positive to negative. So here you can see that current is moving from positive to negative terminal, whereas electrons are moving from negative to positive. So conventionally we can say direction of current is positive to negative and direction of electron is from negative to positive. Moving further, so we have some basic numericals. So let's say the first numerical, which is based on the charge and electrons. So first question, calculate the amount of charge on 20 electrons. So we need to find the charge provided electrons are given. So we can say what is given data here. Given data is number of electrons, which are 20, and we need to find the charge on these 20 electrons. So what is the relation between number of electrons and charge that we have seen in the definition of charge? We know that one charge on one electron, which can be written like this, 1.6 into 10 raised to power minus 19 coulomb. So obviously charge on 20 electron can be written like this, 20 into 1.6 into 10 raised to power minus 19. So which will give us the value. So 1.6 into 20, that is 32, which will give 3.2 into 10 raised to power minus 18 coulomb. Moving to the next question, which is again related with the electron and charge, but here number of electrons we need to find out from the given amount of charge. So calculate the number of electrons in a 5 coulomb of charge. So here charge is given how much? 5 coulomb, and the number of electrons we need to find out. So we know that 1 coulomb of charge is equal to how much electrons? So that is 6.25 into 10 raised to power 18 electrons. So we have 5 coulomb of charge. So we can multiply 5 into 6.25. We will give us the value. It will give us the value 31.25 into 10 raised to power 18 electrons. So moving to the next question, that is related with the current. So see, a current of 0.5 ampere is drawn. That means current is given, and how much time is the given? 10 minutes. That means 0.5 ampere is flowing through the filament of electric bulb for 10 minutes. So we need to convert these minutes into seconds. So we need to find the amount of electric charge in this case. So current is given 0.5 ampere, time is 10 minutes, that means it will be 600 seconds. And question is asked, what is the amount of charge that has been flown? So we know the difference, relation between these three quantities. So we can write I is equal to Q by T. So Q can be written as I into T. So we know the definition of current, I is equal to Q by T. So Q is equal to IIT. So here the formula is not properly written, that is I is equal to Q by T. You can remember, okay. So Q is equal to what? IT. So 0.5 into 600, that will give us the value 300 coulomb. Similarly, in the next question, the same formula we can use, I is equal to Q by T. So find the current flowing through the circuit if 20 coulomb of charge is flowing for 5 seconds. So what is the given data here? Here we need to find the current. Charge is given 20 coulomb and time is given 5 seconds. So we can write the given data in this way. So coulomb, Q is equal to 20 coulomb, that is charge, time is 5 seconds, and we need to find the current flowing through that circuit. So again we have the same relation, I is equal to Q by T. Just put the value of Q 20 divided by time 5, we will get the answer 4 ampere. Moving to the next question, how much work is done? That is based on the definition of potential difference. How much work is done in moving a charge of 2 coulomb across 2 points having potential difference of 12 volt. So here given data is charge, that is 2 coulomb, and potential difference is 12 volt. So we have the relation between these three. As we have to find the work done, we can write potential difference is equal to work done by charge. So we can write work done is equal to potential difference into charge. So we have 12 into 2, that will give us the value 24 joule. And last question in this class, that is if 20 joule of work is done to move the charge between the 2 points of potential difference 6 volt, we have to find the work done, that is 20 joule, and the difference is potential difference is 6 volt. So we can write the formula, V is equal to W by Q. Q is equal to W by V, that is 20 by 6 is equal to 3.33 coulomb. So thanks for watching.